Yeah, we are from the Agency for Geoinformation and Surveying, and we belong to the Authority for Urban Development and Housing. We have around 400 employees working on these four core topics. And just to give you an example, we carry out classic urban surveying work, for example, cadastral surveys. We produce many cartographic products and use satellite navigation with SAPOS. But we also manage geodata. We collect it, we manage it, and we provide it in form of different geodata applications. And we have a real estate cadastry where we inform and give out certificates and extracts on all property-related matters. The core element that combines all four topics is the management of urban data. This is actually the core mission of our agency. It looked different when we prepared this slide, so.
It's an open source software instead of in
Oh, okay, that's why. So you have to use your imagination to make it more beautiful, yeah? The basis for managing our urban data is our Urban Data Platform. And you want to know, you probably want to know who is behind our platform. And it's not a big surprise, it's people, of course. Like, first of all, we have the data owners, and without their data and without their needs, nothing would be possible. There would be no open data platform at all. And within our agency, we have three different departments. Like, we have the department Urban Data Hub, and you are all lucky because my colleague Pierre is the head of this department, and they offer innovation and technology consulting, and they are mainly responsible for expanding the content and the technology of the Urban Data Platform. Then we have the department Urban Data Platform, and they in charge of all operational processes concerning the platform, for example, data management and data integration. And last but not least, Urban Data Solutions, and they translate all requirements into applications. And I'm sure Pierre will show you some of those applications. For us, the Urban Data Platform, it's in Hamburg, it's also known as the data heart of Hamburg. And for us, it's not like a specific server where everything is installed or a new infrastructure, but it's rather a system of systems, because we are using existing IT infrastructures with future IT infrastructures to form this system of system. So it's rather a concept instead of an infrastructure. And to achieve this system-to-system approach, we put together a set of guiding principles that you can see here in those slides. And these principles ensure that real interaction between data owners and all people affected is taking place, and that silos are opened up. And this is how it looks like at the end of the day. Below, you see different information systems from different areas of the city, each containing data from its different areas, but all separated. And these silos are being integrated. Oh, I'm sorry. And the Urban Data Platform collects, aggregates, and connects this data and integrates it into a data warehouse. And from there,
Great.
And from there, it's made available to other systems, services, and applications through a standardized and interoperable service layer. And for everything, we are using OGC standards. And also here, Pierre, he will give you a deep dive in just a moment, and he will show you some of those applications, products, and a real deep dive into the technology. Is it? Because this is a little film. We have a, okay, it's.
Starting.
I don't know, can I start it? It's a little movie, but I can also do it without. No, it's not there. It's going directly. But this is our, you can just slide up and down. This is our Urban Data Platform cockpit. And with this cockpit, we are taking care and we have an overview about the hits of the Urban Data Platform. And it's massive because we have around about 1 billion hits per year. And different users are going to use it, for example, administration, but also private people, companies, and so on and so forth. And you can, in the cockpit, you can choose between topics and organization, which data set is the most popular one in different months, and so on and so forth. And now I would like to pass on to my colleague Pierre, and he will give you a real deep dive into all the stuff I mentioned before.
All right. Thanks. I hope it works. Yeah, thanks for having me as well. We have witnesses here which know that we can do properly styled presentations. So in advance, I did prepare some or add some animations. I hope they're still there. Feels a bit like PowerPoint karaoke, but hey, let's have some fun. So the first thing I would like to highlight was inbound interfaces. So in our Urban Data Platform, we have the system of systems approach, which means that we interconnect various types of systems, as my colleague introduced. So we have the systems for green spaces or for traffic information or whatever. So, and here at this level, we have a certain set of APIs we prefer for, for example, WFST or an MQTT broker to just receive the data and incorporate it into our infrastructure. But anyway, to include and input data, we also use custom APIs. The next step, or another very important step in the process of publishing data through the Urban Data Platform Hamburg, is to enter metadata into the data catalog, which is really, really important to clarify the data, what type of data is, how it's collected, how it's used, who owns the data, and who's responsible, what license is accompanied. Usually it's just an open source license, Germany 2.0 license, so pretty similar to a MIT software license where you can do just anything with the data. But some are still the old version, which is restricted use for, you have to name like the data provider. So unfortunately, not everyone agrees with the MIT spirit. You can do whatever you like with our data. Now, the most interesting part, and I think the most valuable part of our systems approach, because you have a lot of different systems where the data is held, maintained, and also the quality is ensured. But you have one layer, basically a one-stop shop where you can download all this data for free anonymously. So, and there you have a fixed set of APIs. We stick to the OGC APIs because it's a pretty well-known standardization organization, and there are several clients. For each of these APIs, there are more than, well, for the TensorThings API, it's just about 10 different possible clients. But for example, for the web feature service, it's more than 600 different clients available. Some of them, from companies, some of them open source. So we really focus on usability. So there is a tool, you can access this data. It's pretty common and easily done. I think that's it with the architecture. Now I'd like to share some data examples, because we're not restricted to a certain area of expertise. So this is a base map in the background, which shows basically it's an aggregation of our landscape model and the real estate and so on. On top of that, you can see our street tree cadastre. So we have all the street trees in Hamburg mapped. Each one has a number. We know about the height, the width, of the stem width, and so on. And you can identify the tree. You can map how many trees you have there. We also have 3D. I've not included here, but we also have 3D models of the trees. We about 30 of the species occurring there, the most frequent ones. We have modeled and in the 3D version of our data portal, you can look at it. We have LOD3 3D model for the buildings, as well as the street trees with the correct species for the most abundant ones, which is pretty impressive if you see. Then of course we have this official data. So this is the Liegenschaftskataster. Well, doesn't help the German name. Huh? It's a real estate cadastre. So the official borders from the real estate grounds. But also this already mentioned 3D model, which is now, I think a couple of months ago, the last version was published. It's open source, freely available, and we provide it as a CityGML file type. But we do not have this static classical GIS data or 3D data. We also have real-time data, and that I think is where it's most interesting. So we have car counting stations. So we have infrared camera at 400 places in the city, at 400 crossings, and there we count all the cars. And we possess this data in 1 minute intervals. We published it in 5 minute intervals, as well as integrated for 1 hour, 1 day. And up to now, I think we have about 2 years historical data. And this project we were involved, it's run, of course, by the traffic agency here, but we were involved as data experts. And it was, quite impressive. It was a huge budget, of course, 400 different, it's not 400 cameras, it's much more than 400 cameras. It's 400 crossings. So each crossing has 4 to 8 cameras. And well, it was getting into a new age. It was like light years advanced at before. Now we have like 5 minutes data. Before we had a survey manually with students and people once a year. So it's a totally different set of planning. Then we have traffic lights data. I think that was the most challenging data set we have included so far, because it's at the moment, it's about 900 traffic or crossings. And it's the data, the whole data set, all data occurring at the traffic lights. So it's the lightings, as well as if you have public transport, they they announce when they arrive, they check out if they go. So all this data, using this data set, you can reconstruct the whole scheduling, but also the unexpected events and not planned, the spontaneous events. And then you can map through tracks. Usually you make the traffic planning for each crossing separately using a specific software, and then you model inflowing, outflowing traffic. And now you can just select one route through the city, and there you can analyze, well, does the traffic stuck because of the lighting scheme, or how we can optimize this routes through the city, have this main areas free. But we also have data about bike sharing stations, cycling counting stations. So here you know how many rental bikes are available. Here you can see how many. It's pretty much the same as a car counting, but just on 40 different stations for bicycles. And here electric vehicle charging stations. So unfortunately, not all operated in Hamburg. Just the ones run by the city, or ran by the city. And you can also see that because we're not only providing data, but we also try to give an impression about the data. We have some opportunity or some possibility to map it in a small get feature info, we call this. So you have yeah. But we also have some, like novel mobility solutions or challenges. I heard here in Toronto, you don't have this problem with e-scooters on the curbstones, but I think it's also applicable for e-bikes. We already have included the bike sharing data from one company. We have 5 different operating companies for the e-scooters. And of course, there are challenges for wheelchairs, for pedestrians, or and so on, if there's a scooter or whatever as a barrier on the sidewalks. So what do we need as a city? We need decision metrics based on data to influence and govern what the companies do in our city. So what did we do? We created an e-scooter management system. Luckily, our traffic agency convinced all the operating e-scooter operator to share the data with us. So we get all the data in real time. We have like our geo-based data, like maps and districts and so on. Then we have specific data, like no parking zones, the red things you can see here. Or we have mobility hubs where the parking for the e-scooter should be, and also the train stations are located. But then we have this real-time positions. We map all of this into this system, one database, and then we create like key figures, like metrics for how many e-scooters are operated within one certain area in the city, because there's a concession and the operators are allowed like 1,000 for this area. But if you don't control that, they go up to 3,000. That's what, at least that was what we recorded, and that we wanted to have equal competition. So each one was allowed 1,000. Some of them ran 3,000, others 900. So we could control it, steer it back, and then then all of them now, after I think 1.5 year training, most of them keep the limit of about 1,000. There are also a lot of different applications with this to optimize the fleet management for the e-scooters. And yeah, we call this now, as we realized, we call this now a digital twin. So it's an urban digital twin for e-scooter management, because we have like a connection to the real world. We map the real data in real time into the system. We have like steering the real world. We have a digital system where we can manipulate the real world. So we have a connection, we have management, we have regulation, something like that. And so we have, in our opinion, we have a fully functional digital twin, not with every step automated. Some of us, especially this is a conversation between the traffic agency and the operators. It's basically email. It's not like end-to-end digital, but hey, anyway, we have a digital twin. But we have also other projects where we did less of this data wrangling and data inclusion. So this we have done for one of our public transport companies, created like a predictive maintenance approach for predictive deployment for electro buses. So we have a network of streets, and we have a lot of data of air pollution, and we have scheduling where they want to drive, and we have a weather authority. So, and we have a European weather authority. So, and they run a weather model. Great, you can use it. They have an API. So we connected our data to the API from the European Weather Authority. We get a prediction from them. We mapped the prediction, and we were pretty quick solving this issue, and could provide a metric where the company now knows, okay, tomorrow I should schedule my electrobuses on this street, because this has the expected highest air pollution. So we expect the highest air pollution on that route, and not on the one where it was yesterday. You can adjust it by day and so on. It's not the only metric for e-bus deployment, but it's one, and it's I think it's a pretty cool application. And it was not a huge work, because we could connect APIs to a model, had the data already in our platform, and we could just run it and create this value direct out of the available APIs. There's another project where a university of another city developed a new application. So I already told that we publish the traffic lights data, and they use this traffic lights data to create a green light optimal speed advisory system. So so it tells you if it's sufficient that you go faster with your bike, or that you just fade out and brake because you cannot get a green light anyway. So it saves energy. So it's the idea is not to create like a phased lighting scheme that you can just run through as a bicycle, but you can manage your speed, that you have a flow. You can get in a flow riding the track with a bike, because you know when the next traffic light will switch to red. You cannot influence it, but yeah, well, you know, and you can adjust. You can save energy. But we do not only create solutions for the city, we also try to engage with students, with innovators and companies. So we join hackathons. And our role at hackathons is not to create novel solutions or tell them what to do. No, we just provide our data. We say, okay, we have about 600 data sets from the city. Here they are. So this set of APIs you can use, and we help them. Usually we are there about half of the time. And we help them to use the data, to download the data. And of course, we get feedback, how we can optimize, how we can improve our APIs, what is missing, and yeah, what can we do better next time. We also give lectures and workshops in universities, and that's quite a good story, because we have one data set. It's an event cadastre. So you have like the events for the next month in there, and it's there. It's about 2 years. No one cared about that. There's one catalog you can watch on it from the tourism agencies in Hamburg. And yeah, well, but in the last hackathon, couple of months ago, 2 months ago, I think, a student group approached it, and they said, "Oh, well, great! Well, what can you do with?" So we have a student group. We want to have an event. We want to spend a great night together. We know roughly which topic we want to go, what our interests. We know where we live, where we work, but we don't know what is happening in the city. So where to which event, which concert can we go now, and which is located optimally for all our positions, that not one person has to travel like 2 hours and the other one like 30 minutes. And they pitched it, they created a prototype within 24 hours. And I really looking forward to the final presentation next end of June, I think. And where we hope that they go through this idea, and we have like the solution for the city available, maybe. Now, I hope I have not yeah, I just go on. So now I would like to introduce some of the planned innovations. We still, the planned further developments. And so the first is unfortunately in German, because it's a working tool for our data managers as well as our customers. And because we have, at the moment, we have still many manual steps in publishing the data. So we basically plan or have already programmed a client portal where we have the whole flow from starting approaching us and to filling in metadata, registering where are the data source, uploading the data, say how it should be styled in our geo portal, and everything of this flow is totally structured in this. Basically it's a web formula, but we did not have it until now, and it's we hope it makes it easier to include data in the data platform, and maybe we will reach a self-service system on that in the future. Let's see. The second, and I think the most challenging, and I think also the most novel part, is the urban model platform, which is at the moment we have the highest expectations on that. It's kind of a similar approach, the system approach, but not only for data, but for AI models, for ABMs, agent-based models. So in the first step, we want to include a noise simulation for the whole city. So we have this urban model platform which uses the OGC AP processes to standardize access to a noise model. And in an ideal world, if you have implemented fully process, if you're an architect, you have a new construction plan, you just test it against this noise model. Does it fit the requirements? Well, it's not a fully like waterproof noise modeling from a company, but it's the first estimate. And you won't get this silly, if we have also included this wind simulation and heat, maybe you won't get this silly things. So our office building has some doors. It's pretty long, and in Hamburg we have a lot of wind. And when we have a strong wind, some of the doors have to be closed because they are direct at the surface. They should have been like 1 meter inside the building, and then everything would have been fine. If they would have tested it against such an overall general model, they would have seen that directly. And this is what we want to provide, like a standardized way to test things before you do it in the city. And the third thing we're going for at the moment is a geo-based twin. So everyone or many people talk about urban digital twins or digital twins in general. So you have a digital version of physical objects or processes in the real world, but all of them are kind of connected. But a manufacturer creating a motor or someone running a building, he does not think so much about the environment, about the connections. But everything is connected with a foundation. Usually it's a spatial foundation. So you have streets, you have gardens, you have areas, you have places, you have buildings, and everything of this is kind of a foundation of all of this. And this foundation is our vision of this geo-based twin, what we run. At the moment, we provide geo-based data, but this we wanna add, and additionally we want to provide information about construction law, for example, and also about simulations. So like this basic simulation, like I introduced noise simulation, you could also think about a shadow casting simulation for the city. The shadow casting simulation is here included because we already do this. So we have an application where you can, our geoportal, you can switch in 3D mode. Now it's not this LOD2 model, it's LOD3 at the moment with 10 centimeter accuracy. And then we got a pretty cool thing as well in the Connected Urban Twins project, where we're going in the direction of this urban digital twins. We got an application where you can just tap on a building and it vanishes, and you can upload a new 3D model of a new building. And it's right away, it's possible to use the shadow casting with this new model. So you can just check if I have like a tower in that height or a lower one, where does the shadow go? So that's pretty cool. And we hope until project end of next year, we'll finish such an application as we have for the shadow casting, also for the noise modeling. And yeah, well, we try. Based on this geo-based twin, you can do this specifics, this urban digital twins for specific domains. So you can use this foundation and do like traffic management, but you only pick the parts you need. Well, for a traffic optimization twin, you don't need shadow casting, but you may need noise. Or you need the streets or the buildings where the parking spaces and so on. But all of this specific traffic information or environmental information is not part of this foundation for the city. So it does make sense to keep it simple, to layer it. I've just recently learned that layering is a good opportunity to keep data models simple. So I think we went that way naturally. So have this simplified basic infrastructure or structure as a foundation, and then put the specific information on top of that. And this is a bit of advertisement. It's a master portal. It's a web client we've kind of invented in Hamburg, as we were not really happy with the working together with Esri. They did not take up our requirements. And so we started a couple of years ago to create like an own web portal. And it's an open source tool. We're using it already in over 50 different cities. And ministries in Germany. Also, Vienna has took it up, and it gets relaunched with this new fluid mobile optimized design in a couple of weeks. And it's also totally barrier free, so every graphic has a screen reader version and so on. Okay, just this one slide, and yeah, check it out, masterportal.org. We also have a GitHub page for that. So if you have questions, just contact me. Finally, some links on that. So here's the Urban Data Cockpit, which was introduced before. Then we have, of course, we have a web page. It's available in English. Not everything we have is available in English. For example, our metadata catalog, it's unfortunately only in German available. Here's a metadata catalog, and here's a pretty interesting application. It's a master portal version, and there's a music club cadastre. So there we had the case that we have music clubs in Hamburg, and some of them have specific parking places for nightliners. And the zoning of the city has changed, and this parking spaces were used differently. So, and to prevent this from happening again, and we have a private organization collecting all the places where the music clubs are located, and giving them to us. We provide them. We provide additionally the zoning planning, the new plans for the city, and it's intersected. And if their music club is within the area which is newly planned, they get a message and can engage the city that there must be eventually some of the engagement, that we don't have a kindergarten next to a techno club. Yeah, basically that's it. Yeah.